So now we're ready to create our next behavior, which will be walk. In our scripts folder, let's create a new C# script called walk. And we'll open this up in MonoDevelop. Now, just like we did with face direction, let's make walk extend our abstract behavior. Next, we're going to need a public property that'll represent the speed of how fast our player will walk. Here we'll create a public float called speed and set its value to 50. Next, in the update loop, we're going to want to keep track of the left and right key presses. And just like we did in simple movement, we'll apply these to the actual velocity of the rigid body. Here you'll see we're setting up right again, input state. We'll get the button value of input buttons. We'll make sure we use the first item. Then we can duplicate this line and do the same for the left, making it the second item in the array. Next, we'll simply test whether the right or left button is actually being pressed. Next, we'll want to get a reference to the actual speed. Here we're going to call this temp speed, and we'll set it to the speed value. Next, we'll want to calculate the temp speed multiplied by the direction we're facing. Here again, we're going to convert the direction enum that we get from the input state to a float. Then finally, we'll set the body 2D's velocity to a new vector 2 using the velocity x that we calculated and the current velocity of the body itself. You'll notice this is very similar to what we were doing in simple movement, except in this case now, we're going to be able to take advantage of the fact that a lot of the underlying code that makes this work, such as the input state or getting the direction, is actually spread out across smaller classes, and each one is encapsulated. This will allow us to continue to add behaviors to our player in a way that, one, abstracts each of these behaviors and makes sure that they are self-contained and self-aware, and two, when you combine behaviors together, such as this case we'll be using the direction and we'll use walk, the two of them will work together without having to know anything about each other. Let's go back into Unity, select our player, and add the walk component. Now, you'll see we have speed set to 50, and in our input buttons, we're going to need to set this value to 2 so that we can map it to the right and left keys. If we save and run the scene, we should now be able to walk left and right. And now the player actually looks in the direction they're supposed to be facing as they walk. Next, we'll take a look at how to modify this simple walk script to allow the player to also run.